Alkanes and halogenoalkanes. A key fact about where the chain breaks. The chain breaks is random, so you get a different mixture of products every time you crack a carbon. I don't think you need to know this as well. You don't need to know this as well. I'll just double check right now. The specification. This is obviously alkanes, the halogenoalkanes. Alkanes saturated hydrocarbons, petroleum, fractional distillation, cracking, thermal cracking, catalytic cracking. What's it called? On the chain break, so we don't need to know that. That's perfect. Cracking involves breaking carbon-carbon bonds, long chain alkanes into smaller hydrocarbons. So yeah, it does involve breaking carbon-carbon bonds, but therefore breaking long chain alkanes, smaller hydrocarbons. The large hydrocarbons, they don't condense at all. They run to the bottom to a gooey residue. They don't vaporize at all, sorry. And hydrocarbons with lowest boiling point 8, drawn off as gas at the top column. So crude oil vaporized at around 300 degrees, 50 degrees Celsius. The vaporized crude oil is passed into a fractionating column. And the fractionated column, it rises up through the trace, and the crude oil vapor is passed up. The fractional column is cooler than the bottom. Petroleum, a mixture of hydrocarbons made up of alkenes. Cycloalkane, a ring of carbon atoms, 2 hydrogens attached to carbon, CnH2n. What are alkanes? Alkanes are saturated hydrocarbons, and they can only contain single bonds, therefore they are saturated. High temperature, high pressure, produce alkenes. They form alkenes, produce polymers. Produce alkenes, and these alkenes can make polymers. Catalytic cracking, high temperature, slight pressure. Or is it high pressure, slight temperature? Yeah, high temperature, slight pressure. Zeolite catalysts produce aromatic carbons and aromatic hydrocarbons and motor fuels. Alkanes make great fuels because burning a small amount releases loads of energies. Power stations, central heating systems. Hydrocarbon undergoes into complete combustion. We get carbon monoxide gas, and you could be asked to disadvantage carbon monoxide gas, but it's very easy. It's toxic. It also poisonous. It also binds to the same hemoglobin molecules that red blood cells bind to. Therefore, oxygen can't be carried around the body effectively. Soot can be formed by incomplete combustion. Soot causes the breathing problems, and soot buildup means the engines don't work properly. Ground level ozone irritates people's eyes, aggravates respiratory problems, causes lung damage, and it's formed hydrocarbons and nitric oxide react in presence of sunlight. Then the sulfur dioxide dissolves in moisture and converts to sulfuric acid, causing acid rain. Chlorofluorocarbons, unreactive, non-flammable, non-toxic. The cooling gases in fridges, propellants, aerosols. Unreactive, non-flammable, non-toxic. Photochemical reactions, chemicals, reaction started by ultraviolet light. Free radical substitution when a hydrogen atom is replaced by chlorine. Again, I'm pretty sure you don't need to know this. It's not on the specification. And I'm right. Chlorofluorocarbons, where halogen alkane molecules where all hydrogens are replaced by chlorine and bromine. Ozone basically acts as a chemical sunscreen in the upper atmosphere. Free radical, species with unpaired electron, particle with unpaired electron. Free radicals are formed when a covalent bond splits equally, giving 1 electron to each atom. That's why you know with the Cl2 arrow to the 2Cl plus with the dot, covalent bond splits equally, giving 1 electron to each atom, and the unpaired electron makes a free radical reaction reactive. Acid rain destroys trees and vegetation, corrodes buildings, statues, kills fish in lakes. HFCs, hydrofluorocarbons, or hydrocarbons.